In this video, we are going to study chemical thermodynamics and energetics. To understand this better, there are many terms what we should be familiar with. So let us first understand the name what I have written here, that is chemical thermodynamics, what it means. The word chemical here is related to chemical energy. When this chemical energy is formed, when chemical reactions takes place. So due to chemical reactions, the energy which is formed, we call it as chemical energy, and so the term here chemical. Let us split this word now. Thermo is related to heat, and what is dynamics is continuous. Continuous what, students? Continuous flow. So continuous flow of heat within the system or the surrounding, that we will study in this chapter. Now to understand this, the term what we will be using, the first term is energy. You know what is energy? Energy is the capacity to do work. Now what is chemical thermodynamics? Chemical thermodynamics is the branch of chemistry that deals with the study of quantitative relationship between heat and various other forms of energy. You know that energy can neither be created nor be destroyed. Then what it can be done is, it can be transformed from one form to another. And so there is a continuous flow of energy or heat within the system and surrounding. This is what we are going to study in this chapter. So let us see the actual definition of thermodynamics and what is chemical thermodynamics. So this is what is thermodynamics. Thermodynamics is the branch of chemistry that deals with the different forms of energy, the quantitative relationship between them, means the various forms of energies, and the various changes that occur due to physical as well as chemical changes or processes. So this is what is thermodynamics. To understand this thermodynamics better, let us take one example. Say for example, student, I am carrying out a reaction in a test tube. Say for example, Zn plus H2SO4. What I will get is ZnSO4 plus hydrogen gas. Now when I carry out this reaction, there are two types what I can understand here. Either if the reaction wants to proceed, what it can do is, the first case is it can absorb energy from outside or it can release energy outside in this way. So if it absorbs in this way, and if it releases in this way. So there is a continuous transfer of energy between this reaction and the surrounding. What you call this particular reaction here and what you call it other than the reaction, that is surrounding, that we will see now. So whenever there is an energy exchange, that we will see in thermodynamics. Now what this thermodynamics is related to, for that there are some limitations. Now what are the limitations? The first and the very important limitation is, thermodynamics deals with the systems only which are macroscopic in nature. What is the meaning of macroscopic, students? Macroscopic means where the matter is present in bulk. What is the meaning of matter is in bulk? Means atoms, molecules or ions, if they are present in larger amount, then only thermodynamics is applicable. Means what is the other limitation, students? That it does not deal with the systems, does not deals with the systems which are in microscopic amount. What is the meaning of micro? Microscopic means less amount. So thermodynamics does not deal with the systems where the matter is present in less amount. Where the thermodynamic concept is applicable only with the systems which deal with macroscopic or where the matter is present in bulk. Third, very important, it does not deal with the structure of the atom or the internal structure of an atom. It does not depend upon the time what the reaction requires to go to the product side. So it is not related to time also. It does not deal with structure of atom. It does not deal with the systems which are present in lesser amount, that is microscopic properties, what we will not consider for thermodynamics. So it deals only and only with the systems which are present in macroscopic or where the matter is present in bulk. Very important student. The next factor what we will see that thermodynamics deals with only and only initial and final state of the system, and it does not deal with the path which the system utilizes to move from the initial to the final state. Let us understand this concept better. Say for example, if I start from a point A, and starting from point A, if I go to point B, which path I have used is this path what I have used. But a system A goes to path B through various other ways in this way. So what thermodynamics deals with is only with the initial and the final state, irrespective of the path which is followed by the system. So what is important here is thermodynamics deals with the systems which are macroscopic, means where the matter is present in bulk, and the second is it deals only with the initial and the final state of the system, irrespective of the path or the route followed by the system. Now what I am using the word system, so let us understand what is system and what is surrounding. So let us study what is system and surrounding. For that I will consider one example. Suppose this is a room, and in this room I am standing here and I am carrying out a reaction. Now this reaction I am carrying out in a test tube. Say for example, I am carrying out a reaction. Let us take the same example, easy for you to understand. This is what the metal when reacts with acids, they liberate hydrogen. So the first product what I will get is ZnSO4 and H2. Now what will happen student? The reaction is taking place in this particular test tube. Now some energy transfer will take place between this test tube and this area which is other than the test tube. Now here I will call this test tube as system. The part other than system I will call this as surrounding. Now what is your observation is? Your observation is on the test tube. So the part which is under your observation or under thermodynamic consideration, that we call it as system. The part other than system you call it as surrounding. System plus surrounding gives you universe. Now if you just see here, the wall of the test tube what you have is acting as a media, or it is acting as a partition between system and surrounding. So can I say that when a system releases energy or absorbs energy to the surrounding or from the surrounding, it is only through the partition which I am seeing here. So this imaginary partition which is used or which is acting as a exchange medium for the energy, you call it as boundary. So what is universe student? Universe is system plus surrounding, because this is a imaginary partition. Let us take one more example to understand this, and the example is like I am standing in the class. Say for example, this is your classroom and I am standing here. So where is your system now? Some changes which are taking place is here. So this is your system. And where is the surrounding? Surrounding is the part other than system. Whatever the part is there, I will call this as surrounding. Now the question is, where is the wall? There is no wall as such between the system and the surrounding. So what we say that this particular partition which is there, this is an imaginary partition. So the imaginary partition, what you call that students? You call that as boundary. I hope this is clear. So what system and surrounding together makes, system plus surrounding together makes is universe. Our earth also is an example of the best system and surrounding what we can study. Now let us say, for example, this is what the reaction is taking place here at the center. What you will call this? System. The part other than this system, everything I will call it as surrounding. Right, students? The imaginary partition here, that is called as boundary. Now our earth also acts as one of the system where various reaction takes place and the energy gets exchanged between system and surrounding. So what is system? Let us see the definition of system. System, it is the part of universe which is under thermodynamic consideration. What is the meaning of thermodynamic consideration, student? Thermodynamic consideration means where you are observing the energy changes, that is called as system. Then what is surrounding? Surrounding is the part of universe which is other than system. And what is boundary? Can I say boundary is the imaginary partition between system and surrounding? What is the main purpose of this boundary? So this boundary is, the main purpose is exchange of heat or energy. Right, students? Can I say universe is equal to system plus boundary plus surrounding? But as I said, that boundary is an imaginary partition. So can I say it is only a total of system plus surrounding together makes the universe. So what is universe? System plus surrounding makes the universe. Now let us see what the type of systems are. So let us see types of systems. It will be very easy for you to create the definitions. If I take one example, say for example, you have a cup of tea, what your mother offered you, and it is kept on the table. Now as you are watching some important cricket match, you forgot to have your tea. What will happen? After some time, the hot tea or coffee what your mother has offered, it will become cold. Why it becomes cold? Because it has lost the energy. Now, where is the system, students? This is the system and this is the surrounding. The energy is lost to the surrounding. So, this becomes cold. Imagine the same cup of tea, but she kept it now closed. Now, if I keep this closed, what will happen? I am keeping this closed. Now, what will happen? The energy will be lost, but the matter will not get lost. Here, the energy as well as matter is getting lost, right? So, it will take a longer time for the tea to become cold. Here, it will become immediately cold. Now, the same cup of tea, this cup of tea, which is closed, I keep this in an insulating vessel like a thermos flask. Now, what will happen, student? The cold coffee will remain cold, or a hot cup of tea will remain hot for a longer time. Now what you observe here, that the system can exchange energy as well as matter to the surrounding. So this type of systems we call them as open system. Here if you see, it can lose or it can exchange only the energy and not the matter with the surrounding. That we call it as a closed system. And here, neither the energy, here is it exchanging the energy? No. Is it exchanging the matter? No. So neither the energy nor the matter is exchanged with the surrounding. This type of systems, they are called as isolated system. So let us revise, student. What are the three types of the systems what you have? The first is an open system. What is an open system? Open system is one that can exchange energy as well as matter with its surrounding. That we call it as an open system. System that can exchange only energy and not the matter with the surrounding, you call it as a closed system. And if I keep anything which is closed in an insulated flask like the thermos flask, then I will call it as isolated system. Means what is an isolated system? System that can neither exchanges energy nor the matter with the surrounding. That is called a isolated system. So one example what I can give you, please comment or reply that in the comment box, please. I have a bird flying in the air or flying in the sky. What type of system is this? Second example, if you put ice cream in a thermos flask, what type of system is this? So please give me the answer in the comment box. Your first example is the bird which is flying in the sky. What type of system is this? And ice cream in a thermos flask, what I kept. What type of system I will call this? And the third example is flowers that is blossoming. So blossom of a flower, what type of system is this? Please mention the answer in the comment box so that we can go for the next terms what are related to thermodynamics in the next video. Thank you, students.